morning, guys. I just wanted to go over Friday's Socratic problem, and then I'm gonna do a couple practice problems with you, or a model of problem for you, and then you're gonna do one on your own. Okay? So this was Friday's problem. It says Tyrone gathers energy and amplitude data from 4 ocean waves, as shown in the table. According to the table, which equation best represents the relationship between amplitude of an ocean wave and its energy? So that was something we talked about with the gizmo too, so I just kind of want to reinforce this. Okay, so if we look at this table and we start looking at this data, wave W, the amplitude was 1 and the energy was 1. So that really doesn't help us with the equation so much, because so far it looks like it's 1 to 1. But if we look at wave X, the amplitude was 4 and the energy was 16. So you have to start thinking, okay, so when we start with 4, what could get us to 16? You look at wave Y, and the energy was 7. I'm sorry, the amplitude was 7, and the energy was 49. And then wave Z, the amplitude was 10, and the energy was 100. Well, if you're looking at this table and then looking at the options below, does energy always equal amplitude? That is incorrect, because we have our energy column and our amplitude column, and the numbers are not the same all the way going down. Okay? And then if we look at the 1 over E examples, we're not really getting numbers that are fractions either. But what we can see is that 1 squared is equal to 1. 4 squared is equal to 16. 7 squared is equal to 49. And 10 squared is equal to 100. So the correct equation is E equals amplitude squared. So energy equals amplitude squared. Okay? So that is this equation that we're trying to kind of introduce you to with a gizmo and talking about it on Friday with the video. And so going forward, we're going to be using this equation. Okay? So just be aware of that. Okay? And I'm just going to turn that off now. Okay, sorry, I was just playing with the cursor a little bit, trying to make sure it comes back. So I'm going to model this problem for you. So it's Wei-Sheng and Susie use a long piece of rope to model wave motion. They each hold one end of the rope, and Wei-Sheng moves his end up and down, forming a wave. They form wave 1 under one set of conditions and wave 2 under a different set of conditions, as represented by the graphs. So each graph, it's asking you to compare each of the following wave characteristics: wavelength, amplitude, and frequency. So let's take a look at this, okay? So our wavelength for wave 1 goes from here to here, which is about 1.5. And then wave 2, here to here. And again, that's 1.5. So they're both, for wavelength, wave 1 and wave 2, they're the same, okay? Now I'm going to change the color. Okay, let's see. Amplitude. So remember, amplitude is measured from the normal to the top of the wave. So we'll go up like this. So wave 1, the amplitude is about 1. And wave 2, the amplitude is 2, okay? So I'm going to write that down. Amplitude is equal to 1 over here. And then amplitude is equal to 2. Okay. And then the last one we have is frequency. Okay. And then so frequency is how many cycles of a wave in a given amount of time. So if we're looking at this 4-second time frame that's here, because really we have 1, 2, 3, and then it ends at a 4 right here. We have 3 wave cycles that go through here. And then for wave 2, again, we have 3 wave cycles that go through here. So their frequency is the same as well. Okay, so the only thing that's different about these 2 waves is the amplitude. And so part B asks us to describe how many times greater the amount of energy carried by wave 2 is than the amount of energy carried by wave 1. So we look at this, and remember our equation, so energy is equal to amplitude squared. So for wave 1, we have 1 squared, so that means energy is equal to 1, because 1 times 1 is 1. Over here for wave 2, we fill in the same thing, so energy is equal to 2 squared, which is equal to 4. Okay? So now it says how many times the amount of energy carried by wave 2 more than wave 1. So we're not done yet. We just figured out the energy for each wave. To figure out the amount of energy total, we have to take that 4 and divide it by 1, because you're looking at how many times greater something is. So you're forming a ratio. So that means that wave 2 carries 4 times the amount of energy. Okay? Okay. So just remember, when you are doing these problems, make sure you're answering all the questions, okay? And making sure that you include all your steps. So it wasn't just asking us the amplitude of these waves, but how much more energy did wave 2 carry than wave 1. So we had to compare each as well, okay? So let me know if you have any questions about this. Right now, you are going to log onto Socrative and log into the room Vastal, no number. Type in your name, and there is one practice problem for you to do there today, okay? And then you're all done for the day, okay? I'll see you guys later.